All right, welcome to solving quadratics by square root. Now this is a special case. Not every quadratic can be solved this way, but this is a case where if you notice that there's only one x in the whole equation, this can be a lot faster way to solve it. So let's get started. So number one, you're going to do the exact same thing as by factoring. We're going to move all the terms to the same side of the equal sign. And so the first thing we're going to do is subtract 3x. That would be the first thing I do. We've got like terms. It becomes 12x squared equals 243. I'm going to subtract 243. And at this point, I see that we have one variable in the problem. And so I can solve it by the square root method, which is going to be a lot faster. There's no other terms with variables. And then I look for the greatest common factor. The greatest common factor here is 3. So I'm going to divide each term by 3. So it's 3, and that's 4x squared minus 81 equals 0. The greatest common factor doesn't have a variable with it, so that is not going to be part of our answer, our solution. The solutions lie right here. There are two solutions within this factor, the 4x squared minus 81. The biggest exponent always tells you how many solutions there are. So now I am going to take the 4x squared minus 81 equals 0. Again, we only have the one variable in the whole equation, so that means you can get x equals, you can get x by itself, you can isolate it. And what we're going to do is we got to do this reverse order of operations. The order of operations from x would be to square the x, then multiply by 4, then subtract 81. The reverse of that is going to be to add 81 first, then divide by 4. And now with the x squared, 81 doesn't divide by 4 evenly. We're just going to leave it as a fraction. Now when you square root, when you have a square rooting, there are two solutions always when you square something. You have a positive and a negative. So we're going to take this and square root and square are opposite operations. We're going to be left with x equals a positive and a negative, and you're going to square root the numerator and square root the denominator. Square root of 81 is 9. Square root of 4 is 2. So we have two solutions. You can write it like this, or you can write it as a positive 9 over 2 and negative 9 over 2. Either way is just fine. All right, let's take a look at number 1. So we already have the equation equals 0. There's no greatest common factor, and there's only one variable in the problem. So now we can solve. We have from the variable, we have a square, and then subtract 16. We're going to do the reverse order of that, so add 16. And then square root. Remember, when you square root, you have to have a positive and negative. So square root and square are opposites. We have a plus minus square root of 16 is 4. So a positive and negative 4 as a solution. Number 2, we have, I'm going to subtract 125. So 45n squared minus 125 equals 0. There is a greatest common factor of 5. 9n squared minus 25. The greatest common factor does not have a variable with it. All of our solutions are going to lie within the factor 9n squared minus 25. We're going to take the 9n squared minus 25 and set it equal to 0 and do the reverse order of operations from the variable n to get it by itself. So from the n, the order of operations would be to square it first, square n, then it'd be times it by 9, and then subtract 25. So we do the reverse order, add 25 first, bring this up top, we get 9n squared equals 25. Opposite of multiplication is divide. 25 doesn't divide it by 9, so we're going to leave it 25 ninths. We're going to square root, and when you square root the numerator, which is 5, and square root the denominator, which is 3. So you have your two solutions, a positive 5/3 and a negative 5/3. I think I changed number 3 to a different answer, different question. I don't have it actually right here. I'm going to solve the one we have in front of us here. I'm going to first get rid of the denominator. All the denominators, you look for your common denominator, and that would be 9. I'm going to multiply everything by 9 first. So it's 9v squared over 9 minus 144 over 9 equals 9. 9 times 0 is 0. So we have 9 divided by 9 is 1. 1 times v squared is v squared. 144 divided by 9 is 16, and it equals 0. So once you get rid of the denominators, it can be very easy to solve one of these. So we're adding 16. Actually, we have this right up top. Same thing as number 1. And the v is going to equal positive and negative 4. Number 4, I'm going to subtract 5 first to see if there's a greatest common factor, and to also see if there is only one variable, and there is only one variable in the problem. So we are going to continue to solve. So we're going to, from the p, you'd square it first, then you multiply by 25, then subtract 1. So the reverse order is add 1, divide by 25, and p squared equals 1 over 25, square root. When you square root, you have a positive negative, and the p is going to equal square root of 1 is 1, square root of 25 is 5. All right, number 5. So initially you wouldn't see a greatest common factor here. It is 25, but if you don't see that, that's okay. Main reason we can solve it the way we're continually solve is there's one variable in the whole problem. At this point, from the x, I have a square, then I'd multiply by 25/9, and then I'm subtracting 25. Do the reverse of that. So we're going to add 25 first. Then multiply by 9 over 25. Nine times 25 is 225 over 25. 225 divided by 25 is 9. Take a look up here. You have a multiply by 25. So you multiply by 25 and you have a divide by 25. What that actually does, anytime that happens, is they simplify. And then you square root, you have a positive and negative, square root and square, positive and negative 3. Number 6. For this problem, I know that there's not going to be, with the parentheses, there's not going to be a greatest common factor. For this, I have to think from the x, what's the order of operations? You have to add 8 first from the x. After that, you would square it. And lastly, you would multiply by 2. You need to do the reverse order of that. So the opposite of multiply by 2 is divide by 2. So that would be your first step in solving this equation. Proper order of operations, then doing the reverse. 22 divided by 2 is 11. We'd have to square root. So it uncovers the x plus 8. And the square root of 11, you have a positive and negative square root of 11. Now, lastly, we would subtract 8 and subtract 8. Typically, you subtract 8 at the end, but you usually do not want the problem to look for the subtract 8. After a square root, we typically don't write a plus or minus anything. No operations go after the square root. And if you were to accidentally write the square root over the top of the negative 8, then it is totally wrong. So what we typically do is we take that negative 8 and we put it out front. So you're going to want the x equals a negative 8 plus minus square root 11. Number 7, I changed it, so make sure you change it to the one you see here. For this one, I got to think about, it's very similar to number 6. Order of operations from the x, we have subtract 7, then you have square, then times 4, And lastly, we have subtract 42. So you got to do the reverse order of that. So last thing I said was subtract 42, so I got to add 42. Then the second last thing, order of operations, the reverse order is multiply by 4, so we divide by 4. 20 divided by 4 is 5, so anytime you can simplify, always do it at any step. Then we have square root. So we have x minus 7 equals a positive and negative square root of 5. And then add 7, and we're not going to do it at the end. We're going to do it, put the positive 7 at the beginning. All right, moving on. Number 8. No greatest common factor. We're going to subtract 81. You might think this is just like any other problem we've done. There's a little wrinkle. We're going to multiply by 9 over 4, multiply by the reciprocal one. You have that fraction. That's going to be negative 729 over 4. Now when we square root, this is where it gets different. And I haven't talked about this. We're going to talk about more in class in the near future, but this is the first time I'm going to show it to you. You can't do the square root of negative 729. That is a non-real answer. But what it actually is, it's called imaginary. For now, anytime you have the square root of a negative number, we're going to take the square root of the positive first. So x equals square root of 729 is 27, I believe. So it's 27, and the square root of a negative number, we're just going to bring that out as I. So that's square root of a negative. Anytime you see square root of a negative, we're just going to bring it out as I. You don't have to write the I like I write it. I just write it that way because then it doesn't look like any operation at all. And then the square root of 4 is 2. And so our answer is a positive 27i over 2 and a negative 27i over 2. All right, let's continue. I'm going to, on number 9, I'm going to add 2a squared, add 2a squared. I'm going to subtract 2a, and I'm going to add 2. So that's 4a squared. The 2a's are going to cancel. Plus 4 equals 0. All right, we have greatest common factor is 4. And now we have all of our solutions are coming from the factor a squared plus 1 in the quadratic, since that is a quadratic. We're going to subtract 1. When you square root, you have the square root of a negative. Square root of 1 is 1, and then the square root of the negative is going to be I. It's actually the square root of negative 1 is I. So 1 times I is actually I. So your actual answer is a positive and negative I. If you left it as 1i right now, I'm cool with that. I'm totally fine with that. We'll get to this a little bit more later on in the unit. All right, number 10, let's look at that. Greatest common factor, there is a 5, I believe. So I'm dividing a 5 out. We got 25 minus 16 x squared equals 0. All my solutions are coming from the factor 25 minus 16x squared. And so I'm going to subtract 25. Negative 16x squared equals negative 25. Over 16, square root. X is going to equal positive negative 5 over 4. There's no negatives there. Negative divided by negative is a positive, turns out to be positive, so there's no imaginary. All right, number 11, we have from the x, we have to look at what operations are we doing. From the x, the first thing would be multiply by negative 3. Then it'd be take the 4 and subtract it, I guess. And then after that, it'd be the squaring. And lastly, you'd have to multiply by 16. Reverse order of that is divide by 16. Four 16ths can be reduced to 1/4. We take the square root. When you square root something when solving, you always do the positive and negative. Square root of 1 is 1. Square root of 4 is 2. Now we actually have this broken into two problems. We actually have, you have 4 minus 3x, and that's going to equal a positive 1/2. And you're going to have 4 minus 3x, and it's going to equal a negative 1/2. Because you have the positive and negative, we have to break it into two problems. You can't do the positive and negative at the same time. Like when I subtract 4, you can't do that with a positive and negative 1/2 in one problem. You got to break it into two problems. So we have 4 is the same thing as 8. I need it to be denominators the same, so I'm actually going to erase that. Instead of minus 4, I'm going to write minus 8/2, so they have the like denominators. And that would be a negative 7/2. And then we're going to divide by negative 3, but that really looks really weird, divided by negative 3. So instead of dividing, this is a weird time, but we're going to multiply by the reciprocal, negative 1/3. Since it's already a fraction, it's going to make it easier to multiply. Negative times a negative is a positive, and then 7/6. Multiply across your numerators, multiply across your denominators. All right, let's do the same thing over here on the second equation. So I have subtract 4, and remember minus 4, that's going to be the same thing as 8/2. Here we have a negative 3x. Negative 1 minus 8 is a negative 9/2. I'm going to multiply by the reciprocal, so then I can multiply by the fraction instead of dividing when you have a fraction. We have negative 9 times negative 1 is a positive 9. 2 times 3 is 6. This can be reduced to 3/2. So x is also going to equal 3/2. So there are two answers to number 11. Number 12, done very similarly. Order of operations from the x would be to multiply by 5, then it's subtract 4, then we have square, then we would have multiply by 3, and lastly, I ran out of colors. Let's choose this. We would subtract 25. So I need the reverse order of operations. I got to add 25. 3 times 5x minus 4 squared equals 27. Divide by 3. I have 5x minus 4 squared equals 9. Square root. We have 5x minus 4 equals a positive negative 3. Now, because this has more going on with the problem, I need to break it into two problems. I have 5x minus 4 equals a positive 3, and 5x minus 4 equals a negative 3. There are more operations to go with the 3, so I need to continue with this, breaking it up. So you'd add 4 and divide by 5. Get x equals 7/5 as a solution. Add 4, 1, divide by 5. And we get x equals 1/5. I hope this helps. Come to class with any questions.